AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 5, Classification Analysis. Chapter 5, Section 3, Logistic Regression. In this section, we're going to learn about logistic regression, one of the most common methods used for classification, especially when the outcome has only two possible values, like yes or no, or adult versus child. By the end of this lesson, you'll understand how logistic regression differs from linear regression, when to use it, what odds and logits mean, and how to interpret a logistic regression model. Linear versus logistic regression. Let's start with what you already know, linear regression. Linear regression predicts a continuous outcome, for example, predicting someone's income based on their years of education. It uses a straight line formula, y equals mx plus b. That works fine when the outcome can take on any value, like a salary that could be $40,000, $50,000, or $60,000. But what if your outcome is binary, for example, whether a person is an adult or a child? Now your outcome can only be 0 or 1, not a range of values. If you tried to use linear regression, you'd get predictions that don't make sense, like 1.3 or minus 0.2, which can't represent yes or no. That's why we use logistic regression. It's designed for binary outcomes and predicts the probability that an event occurs, for example, the probability someone is an adult based on their height. If that probability is at least 0.5, we classify them as an adult. Otherwise, we classify them as a child. Odds and odds ratios. To understand how logistic regression works, we first need to talk about odds. The odds of something happening are the ratio of the probability it happens to the probability it does not happen. For example, if the probability of winning is 1/3, the probability of not winning is 2/3. So the odds are 1 to 2, meaning 1 win for every 2 losses. An odds ratio compares two odds, for instance, the odds of success in one group versus another. The logit function. Logistic regression doesn't model probabilities directly, it models something called the logit, which is just the natural log of the odds. The logit stretches out the probability scale so it can range from negative infinity to positive infinity. At a probability of 0.5, a 50-50 chance, the logit equals 0. At lower probabilities, the logit is negative. At higher probabilities, it's positive. This helps the model handle binary outcomes smoothly. The logistic regression model. In a logistic regression equation, we model the logit of the probability as a straight line function of our predictors. That means we take the log of the odds and express it as b plus bx. Once we fit the model, we can use it to predict probabilities using the logistic function, an S-shaped curve that maps any input back to a probability between 0 and 1. So if we plug in a person's height, the model might tell us there's an 80% chance that person is an adult. Example, predicting adult status by height. Imagine we collect data on height and whether someone is an adult or a child. The software fits the logistic model and finds the best values for B and B. We can then calculate the predicted probability for each height. If the predicted probability is at least 0.5, we classify that person as an adult. If it's below 0.5, we classify them as a child. Logistic regression as classification. Because logistic regression produces probabilities, we can turn those probabilities into class labels using a threshold, usually 0.5. But sometimes the model can misclassify cases, especially if they fall close to the threshold. To check how well the model performs, we use a confusion matrix, which compares the predicted labels with the actual labels. This lets us count how many predictions were correct and how many were wrong. Using logistic regression with multiple predictors. We can also include multiple predictors in a logistic regression model, for example, both height and weight. This can improve accuracy, but we have to be careful not to overcomplicate the model. Simpler models are often easier to interpret and perform just as well. The logistic regression curve. The logistic regression curve has that distinctive S-shape. The y-axis represents the predicted probability, and the 0.5 point on that curve marks the boundary between the two classes. It's flexible enough to fit many types of binary data, which is why logistic regression is so widely used in data mining and statistics. Wrap up. So to summarize, linear regression predicts continuous outcomes, while logistic regression predicts binary ones. Logistic regression models the logit, the log of the odds, as a linear function of the predictors. It outputs probabilities between 0 and 1 that we can use for classification. And we can evaluate how well it performs with a confusion matrix. Logistic regression may sound complex, but conceptually it's just a smart way of turning a straight-line model into one that predicts categories, using probability as the bridge between them.